So you're headed, where are you going? You going any place interesting?
Chicago and then Michigan.
Yeah, well, those are interesting places if you haven't been there. All right, I want to move on in geometry, but I want to make sure you know how to do right triangles. Okay, so we're not going to move on until you know how to do right triangles.
Okay.
Okay, number one, what's X?
Okay, so it's 4 squared plus 7 squared equals, so then it would be 16 plus 49, then 16, that would be 65, and then you would have to take the, and then you'd square root it, right?
Yeah. Now, that's the way a lot of people do it. I'd like you to do it a more direct way. Only because you're going to have to do this hundreds of times. So let's teach you how to do it quicker.
Okay.
Okay. X. Any side of a right triangle, remember this, always starts out the answer with square root of. Just remember that. Always, always starts out the answer with square root of.
Okay.
And it doesn't matter which side you're solving for. Whether you're solving for the hypotenuse, which is number 1, or in question number 2, we're going to solve for one of the short sides. Doesn't matter. Always starts out square root of. That's what I want you to remember. Okay? So this answer is square root of 65. And it turns out that that's simplified. I can't really reduce that. There are no factors of 65 that are perfect squares.
Yeah.
Okay. In number 2, this one over here, what's X? And it always starts out square root of, even though it's the short side. Notice that this is not the hypotenuse that I'm solving for in number 2.
X equals 32.
Tell me what it is exactly. It's 6 squared minus, that's the way I want you to give me the answer.
Yeah, 6 squared minus 2 squared.
Yeah, because that tells me you know how to do it.
Yeah, I did in my head. I did that exact thing just in my head.
That's fine. So it's the square root of 36 minus 4, so it's the square root of 32. Now this one does happen to reduce. In other words, you would lose credit if you ever gave an answer like that on a math test.
Yeah.
What's the square root of 32 equal to? And I don't mean decimal. I mean always, always leave it in radical format.
4 and 8.
Okay.
And that'd be 2 and 4.
Well, hold on. What's the next step?
Out, so to 2 and 2 and 2 and 4.
That's the next step. And then square root of 8 happens to be square root of 4 times square root of 2. And then square root of 4 is 2, so 2 times 2 is 4. So that's the final answer.
Yeah.
Now, notice that I could have gotten there just a little bit quicker if I would have noticed that square root of 32 is the square root of 16 times the square root of 2, right?
Mm-hmm.
And 16 is a perfect square number. So that immediately, in one step, becomes 4 square root of 2. So,
Yeah.
when you're reducing these radicals, if you can figure out factors where one of the factors is the maximum perfect square, you're going to do it the shortest possible way. But even if you didn't know that, even if you broke it down into square root of 8 times square root of 4, you still get the same answer. It just takes you a little bit longer.
Mm-hmm.
Okay, well, let's talk about that for a second. What's this equal to?
So it's the square root of 100 times 2.
Times
That's how
the
you say
square root
it.
times the square root of 2.
Yeah, so then it would be 10 square root 2.
Perfect. That's the answer. And notice I could have done this many ways. I could have done square root of 50 times square root of 4, which would have been 2 root 50. You with me?
Yeah.
Well, that's the same as 2 root 25 times root 2, because 50 is 25 times 2. Square root of 25 is 5. 5 times 2 is 10. So I get to the same answer. It's always going to be the correct answer. It doesn't matter how you do these problems. You get to the same answer every time. It's just a question about how quickly you do it.
Mm-hmm.
So the secret kinda is, well, it's not really a secret because there's nothing wrong with doing this as square root of 50 times square root of 4. It just takes an extra 30 seconds. So if you're looking to do math in the fastest way possible, then you're looking for factors of 200, one of which is a perfect square. That's the quickest way to get there.
Yeah.
That's 10 root 2. Okay? Now, what I'd like you to do, and this is hard because, and it's not even normal. In other words, most of the time, when there is an equation that governs anything, I ask people to memorize the original equation, and then you can manipulate it however you like.
Mm-hmm.
So when we were solving for x in the first problem, you could go back to the Pythagorean Theorem and solve for it. And when I was solving for x in the second problem, I could go back to the Pythagorean Theorem and solve for it. Problem with doing that is that you always have lots of more math to do. Okay? So, here's what I'd like you to do. This is very, very special, and this is probably the only formula I ever ask my students to do this with. And that is, if you're solving for a hypotenuse, then x is equal to the square root of the other two sides squared. Okay? Plain and simple.
Yeah.
Problem 1. If I'm solving for one of the short sides, problem 2, then it's always the hypotenuse squared minus the other short side squared.
Mm-hmm.
And these are the two that I want you to remember, because it allows you to solve right triangles really quickly. And that's something you have to do a lot of in geometry, is solving right triangles. Not just in geometry, but when you take your ACT test, when you take your SAT test to get into college, you just aren't going to believe how many right triangles you have to solve.
Mm-hmm.
And you don't want to have to go back to the Pythagorean Theorem every single time. It's much, much easier to memorize these two formulas than it is to go back to the Pythagorean Theorem every time. Okay? So, let me give you some more. I want to make sure you're really good at this. And trust me, if you're good at this, you're going to have no problems with geometry.
Okay.
So right triangle, I'm just going to make up numbers. What is that?
That would be, so 5 squared plus 6 squared would be 25 plus
Hold on.
36.
Hold on. I want always the first words out of your mouth to be square root of.
The square root of 5 squared plus 6 squared.
Perfect. That's all I care about.
Okay.
Now, let's solve for one of the short sides. This time, x is one of the short sides, right? The hypotenuse is always the longest side.
Yeah, so it'd be the square root of 7x minus 5x. 5 squared.
Minus 5 squared. Exactly. It's really easy. In other words, once you get it, you get it. Hold on. And it doesn't really matter which short side I'm giving you. Notice. In other words, when you're solving for a short side, it's always the hypotenuse squared minus the other short side squared. So what's x here?
X would be the square root of 7 squared minus 3 squared.
Perfect. Perfect. Okay. Never forget what you've learned tonight. And I mean that. That's how important it is. Okay?
Uh-huh.
Now, that takes care of this problem and this problem. Still have the third problem that is also one of the most important problems in geometry. Notice that in this problem, I don't have two sides. I only have one side. But it's a 30-60 triangle. It's a 30-60-90 triangle. Okay? That's one of the special triangles. There's two special triangles. There's a 30-60-90 triangle, and there's a 45-45-90 triangle. You want to be able to solve all of these. Now, even though you only have one side of the triangle, so you really can't use the Pythagorean Theorem,
No.
how do you solve for x and y?
So it would be,
What's
I need the other.
dimensions? Tell me the dimensions of my unit 30-60 triangle. That's what you need to know.
Yeah.
Can't
Would it
solve
be
this unless you memorize these dimensions. It's called a unit triangle. What's opposite the 30?
1?
Good.
Or no?
No,
Yeah.
you're right. That's why I call it the unit triangle.
Yeah.
I wouldn't call it the unit triangle unless there was a 1 involved.
Mm-hmm.
Okay. What's opposite the 60?
Would it be square root of 2
Square root of
or 3?
And then that's 2. Now notice that if I
Wait, so how did you
this
get
as a problem, what would x be?
X would be
What's the first words out of your mouth?
unit.
Square root of.
Yeah. It would be the square root of square root of 3 over 1.
Well, one's short side is 1. The other short side is square root of 3, but we're going to square it. Well, what's 1 squared?
1.
What's the square root of 3 squared?
9. The square root of 9.
Well, the square root of x squared is always x. So it's 3.
Okay.
And you're right, it's the square root of 9. But just remember that when you're taking the square of the square root of a number, it's always going to be whatever that number is. So it's 3.
Yeah.
Which is the square root of 4, which is 2, meaning x is 2. Okay? So I want you to memorize that triangle. And I can't emphasize it heavily enough. I don't want you to ever forget this. And this is automatic. In other words, there's nothing to memorize there. This is called the unit triangle. So opposite the shortest angle is always 1. So the only two numbers you really have to memorize are square root of 3 and 2. And in fact, the only number you have to memorize is square root of 3, because you can always calculate 2, right? Using the Pythagorean Theorem. But this is a very, very special triangle. You want to memorize this.
But my question is, how did you get root 3?
Well, that's just the dimensions. In other words, in my 30, 60, 90 triangle, the side opposite 30 is 1. The side opposite 60 is root 3, which is like 1.7. And then the side opposite the hypotenuse, or the 90-degree angle rather, is 2. So just memorize that. Okay? And the reason is that this triangle over here, that's a similar triangle. It's similar because it has the exact same 3 angles. It's a 30, 60, 90. What's the similarity ratio? Big to little. Always big to little.
2 over 1?
Yes. So, what does that make y?
Y would be 2.
What does it make x?
2 root 3.
You got it. That is the essence of similar triangles. Whenever you're looking at a similar triangle to one of these special triangles, this is the logic you always want to use. You want to figure out what the similarity ratio is, and then you want to figure out what each side is. So even though you were only given one side, you can still figure it out. Now, what if I make it a little harder? What's the similarity ratio now?
.5.
Don't give me it as a decimal. Always, always, always leave it as radical. Now, you're going to take tests this year, and sometimes you'll take a test and your teacher might ask you to put it as a decimal. But proper mathematics is you never do that.
Yeah, so it would be √7/2.
That's it. That's the similarity ratio. In other words, it's the same side of the bigger triangle divided by the same side of the smaller triangle. Now, what's y?
Y would be 1 over... No.
It's 1 times the similarity ratio.
Yeah, so just it would be √2.
Same thing. The similarity ratio, right?
Yeah.
What's x?
X would be it would be
multiply the similarity ratio times
√21/2.
Yes. √21/2. And believe it or not, that's simplified. √21 cannot be broken down. It's √7 times √3, but neither one of those is a perfect square. So √21 is the simplified answer. Okay?
Yeah.
Now, that's pretty good. I see that's 8:02. We started a little bit late. Let me just give you one more problem.
Okay.
And again, it has to do with these special right triangles. What are the dimensions of this unit triangle? And this is important. You need to know the dimensions of the unit triangle.
So it'd be 1 on the left side, 1 on,
No, 1 on the right side. In other words, when you have an isosceles, this happens to be an isosceles triangle. Sides are equal. And if you have equal angles, then the sides opposite them have to also be equal. There's no way that could be 1 and that could be something other than 1. Okay? So that's 1, 1. What's the hypotenuse? You can actually figure this out from the Pythagorean Theorem. What's x?
X would be two.
What's the formula?
Well, 1 squared.
Hold on.
The root of 1 squared.
What are the first words out of your mouth need to be?
The root of.
Square root of. Now
1 squared.
Goes inside there?
1 squared plus 1 squared.
What is 1 squared plus 1 squared?
2.
Square root of 2.
Yeah.
Okay? So that are the dimensions of the unit 45, 45, 90 triangle. Okay? So, if I gave you a similar triangle that was also 45, 45, 90, but this was square root of 7, what's x and y? Excuse me.
Excuse me. 2 or 7?
Yeah, it's supposed to be a 7.
Oh, sorry.
Looking at 2 when I wrote it.
Then it would be...
It's a similarity ratio. It's always the first question.
Yeah. It would be 7 over 2.
Root 7 over root 2.
Yeah, that's what I meant. That's what I meant.
Okay, so what's
And then
y?
y would be root 7 over root 2.
What's x?
X would be root 7 over root 2.
Okay. What's wrong with those answers? That's correct. In other words, if you put that into a calculator, that'll be the right answer. But there's something wrong with that answer. What is it?
The main number is rooted?
You have a radical in the denominator. In other words,
oh, you gotta multiply it by.
That's not a very good answer.
You gotta multiply it by root 2.
Okay, so tell me what that becomes.
It would be root 14 over 2.
Very good. And that's the proper answer. In other words, you never want to give an answer that has a final answer, I should say, that has a irrational number in the denominator. Well, root 14 over root 2 has a rational number in the denominator. The irrational number's in the numerator, but that's okay. We don't care if we have an irrational number in the numerator. We just cannot have one in the denominator. So whenever you get an answer like that, you have to what's called rationalize the denominator. Same number, if you put both numbers, in other words, if you put root 14 over 2 into a calculator, you'll get the same exact thing as if you put root 7 over root 2 into a calculator. But I guarantee you, you give this on a test, you'll lose points. You give this on a test, it'll be the perfect answer.
Yeah.
All right. Good place to stop. Daniel, yeah. I think we have got you so you have mastered right triangles. We'll go on to something else next time.
Okay, sweet. Thanks.
Bye-bye.
Bye.